simplify the expression. So when you simplify the expression or proving or verifying the trig identity, you usually will need some basic identity that helpful, which is the Pythagorean identity. The first one will be sine square plus cosine square is equal 1. And then 1 plus tangent square equals secant square. 1 plus cotangent square is equal cosecant square. You will need these identity in order to apply the simplified expression. And also, you may also know how to do tangent data is sine data over cosine data. Cotangent data is equal cosine data over sine data. Okay, and of course, these trig identity can always write back and forth. They also equivalent. So, for example, sine square plus cosine square equal 1. We can always write as an equivalent expression like sine square is equal to 1 minus cosine square. And then cosine square is actually equal 1 minus sine square. Okay, so these are equivalent and generated from the original equation. So you can isolate them into any expression you want because they are equivalent, okay? And they are identity. So we can generate it. Now let's take a look at the example 3, and we want to simplify the expression. So first of all, we're gonna have to look at, is there anything that we can do on the problem? I see tangent square. Okay, tangent square. So the basic identity. If I have tangent square plus 1, then I'm gonna have secant square, but there's no number 1 there. But on the next term, we just see sine x is equal, multiply cosecant x. Wait a minute, sine x and cosecant x, they have any relation? Yes, sine x is a reciprocal of the cosecant x, right? So sine is the reciprocal of cosecant, or cosecant x can be written as 1 over sine. Secant can be written as 1 over cosine, right? So cosecant can be written as 1 over sine. I'm gonna leave the tangent square there a minute, and I'm gonna take care of the cosecant by writing as 1 over sine x. So look like sine x and sine x cancel out. If I cancel that, then we're gonna have tangent square x plus 1. Oh, perfect. Tangent square x is actually equal to secant square x. So this complicated expression right here can be simplified down to just secant square x. Okay, so the other way to say, we can say tangent square x plus sine x cosine x is equal secant square x. Okay, so that is simplified expression. Now we're gonna do the verify each equation. So it's mean a little bit different than the one above. The one above, I give you one expression and I want to find out the other one. So tangent square x plus sine x cosecant x is equal secant square x. Okay, so the one above, they give you one expression and you want to find out the one that they equal. For example 4, they give you the one that they are equal, but they want you to verify them. Is that true? So when this is the question, we cannot trick this is true. We don't know secant square x over tangent x. Is that equal to secant x times cosecant x or not? So what we have to do, we have to use one size, one expression. And we do the simplify to get the other side and see is that same as this one. Okay, so to verify each equation, we will first choose one side of the equation to simplify. Okay, so how do we choose one side of the equation? Can we choose any side we want? Yes, you can choose any side you want, but the trick is choose the one that is look complicated. So you have more things to simplify. So I'm gonna choose the left-hand side in this case. So cause this look more complicating for me. So I'm gonna choose secant square x over tangent x. All right, so now we're gonna see is there any identity so I can simplify this expression to something look like the one that secant x times cosecant x. Okay, so I can see there's a square. For the square, I have the identity is 1 plus tangent square x. So I'm gonna go ahead and do, okay, this is gonna be 1 plus tangent square x all over tangent x. But wait a minute, when I do it like this, I don't see anything that I can simplify further. However, it looks like a fraction with 2 terms on the numerator and 1 term in the denominator. I'm gonna break down the fraction by doing 1 divide tangent x plus tangent square x over tangent x. Okay, if I follow the flow, I can see 1 over tangent x is actually 1 over tangent x is actually cotangent x. Okay, if I follow the flow, I will have cotangent x plus tangent x. But wait a minute, it doesn't look like the one on the right-hand side because the one on the right-hand side is actually secant and cosecant. So how do we gonna make cotangent and tangent back to secant and cosecant? What we know about cotangent is cosine x over sine x. And tangent is sine x over cosine x. So we can use the algebra, simplify it. So we multiply cosine and cosine. We're going to have cosine square x plus, and we multiply sine with sine. We will have sine square x. And the bottom will be sine times cosine x. Okay, still does not look like the same at the left-hand side, but can we simplify more? Yeah, we does see sine square plus cosine square is equal what? Is equal to 1, right? So it's 1 over sine x times cosine x. Look like we are getting there. What is 1 over sine x? 1 over sine x is cosecant x. And 1 over cosine x is secant x. So we're going to have cosecant x times secant x at the answer. And we actually already successful to simplify or verify our expression. So it's look like this, okay? So the left-hand side is actually equal to the right-hand side. So this is an identity. Okay, so that's how you showing an identity. Of course, to proving identity, then not just one flow to getting the answer. Some of you may also approaching from the beginning, instead of doing secant square is 1 plus tangent square. You can also do secant is 1 over cosine square x, and tangent is sine over cosine. If I multiply cosine square on top and bottom, I will get my result quickly than doing this flow. Okay, but anyway, proving it's just your own, it's just your own path. Okay, it's the own critical thinking. Depend on whoever you are, you may have a different approaching to the final answer. So everyone may have a different approach. No problem, as long as you can proving this an identity or you can verify it, that's fine. Okay. Now let's go look at the second one. We want to verify this identity also. So choose one side to simplify, okay? So we're gonna choose the left-hand side instead of the right-hand side because it look like this left-hand side is more complicating. So I will choose from that one to approach. And now, if you notice that on the left-hand side, the identity written in the fraction form, and there are two fractions of that. So whenever you see multiple fraction, the first thing that we may want to think of is simplify the fraction. Okay, so combine these two, combine the fraction first. So I'm gonna combine the fraction by cross multiple like this. So we have 1 times 1 plus sine x. And then because the addition in the middle, so we have plus 1 times 1 minus sine x. And then all over the bottom, these two multiply, we have 1 minus sine x times 1 plus sine x. All right, so after we do the combined fraction, we're gonna have to simplify the fraction. So on the numerator, 1 times whatever, it just do whatever, right? So 1 times 1 plus sine x is do 1 plus sine x. So nothing changed. So I can feel free to remove the 1. We don't need that. And then we're gonna combine like terms. So 1 plus 1 will be 2. And then plus sine x minus sine x will be 0. So 2 plus 0, which is 2. And in the denominator, we have 1 minus sine x times 1 plus sine x. You can do the FOIL or distribution to get the result, or you can use the formula a minus b times a plus b is actually a squared plus minus b squared. So a minus b times a plus b will be the first term square minus the second term square. So my first term is 1. So I have 1 square minus the second term square. So gonna be sine square x. So 1 square is still 1, so we don't need to write the square. So 2 over 1 minus sine square is 2 over, what 1 minus sine square is? We does c square. With our c square, when we see square, we will think of the Pythagorean theorem. So the identity right here, you have sine square is 1 plus cosine square is 1. Then sine square is 1 minus cosine square. Or cosine square is 1 minus sine square. We have sine square plus cosine square is 1. Then cosine square is 1 minus sine square. So our expression finally will become cosine square. So 2 over cosine square will be 2 secant square, because secant is the reciprocal of cosine. So which is the right hand side. So we done the proof. So we have we actually already done proving the identity.